Yesterday we looked at the least common multiple. Today we're talking about the greatest common factor. Those two things are really easy to mix up, and they're things that you learned since fifth grade. We're going over them today because we're building a tool belt, and this tool belt is for Monday's lesson on fractions. If we don't have those tools in the tool belt that we can like fluently get out in 3 seconds, the fractions unit will be a mess, and we'll get to the test and just like be in a disarray and not be able to feel confident. Quick side story, I was trying to put in flooring this summer, and I had like all the flooring ripped out, put in new wood flooring, and I was like working on a room. It took me like 5 hours, almost the entire day to do a room. Then my father-in-law came over, and he whipped out one room, the same space, in literally like 30 minutes. It took him like a sixth of the time, and I was like, how is he doing this? And in my mind, I was thinking back to myself doing it the day before he did, and I would like start hammering a piece of wood in, and then I would like turn to get the other piece, then I'd like grab a little like spacer tool, but I was like, shoot, I've lost the spacer tool, so I'd go back and try to find the other tool, then I'd turn around and my hammer was being like run away by my toddler, and I was like, oh no, and my tools were just everywhere. And then I was watching my father-in-law, and he had this belt, and he was just like rapid fire. He looked like an octopus with 8 arms, but he was just like whipping it out. And I was like, oh my gosh, he has a tool belt. So I went and bought a tool belt. And I got it done in like 2 hours, not half an hour, but it was pretty good. That's the same idea. This stuff is going to be like our tool belt. You're going to just be whipping out LCM, GCF when we get to Monday's lesson. Today, though, is about GCF, greatest common factor. And when you're thinking of greatest common factor, it is not this. Don't write it. We are not skip counting. That is the least common multiple. When you think of GCF, you're going to make a birthday cake. And your birthday cake looks like this. Voice, Aiden, 1. You're going to put an 8 and a 12 inside the birthday cake. And in your mind, you're thinking, what is a number that I can evenly divide 8 by and 12 by? I want the lowest number to start out with. So I'm going to go with, Sierra, what do you think? 2. Any other guesses? Someone had probably a... 4. You had a 4, but let's start with a 2. 4 would work. Let's just see what happens if we have a 2. So 2 is even. 8 and 12 are even. That's a trick. If there's even numbers, it always divides by 2. So 8 divided by 2 is 4. You can do this mentally when you get to independent work. Today I want you to show this in notes though. And then 12 divided by 2. Board to paper. Make sure you have a 6 there. So 4 and 6 work. Are there other numbers that can divide evenly into 4 and 6? Jackson? No, we're going to divide 4 by a number, not 110 by a number. But I like your idea. You're thinking of multiples of 4 and 6, which is yesterday. Okay, so flip that thinking. We're doing greatest common factors. What do you think, Lauren? 2. Yeah, we can divide the 2 again. 4 divided by 2, and 6 divided by 2. That works. And that makes a 2 and a 3. Put a 2 on the outside because that's what we divided. When you get to 2 and 3, put a comma, it's not 23. Can I divide any number besides 1 by 2 and 3? No, those are both prime numbers. Nothing can divide evenly into those and make a whole number. So I stop. This is my birthday cake. It's upside down. You can put a little candle if you want. My daughter's turning 2 today, so I'll put 2 candles for her. And then you have a 2 and a 2 on the outside. So what do I do with that? Well, when you have any more than just one number, we're going to take those 2 and multiply them. That is your GCF. 4 goes in evenly to 8, and 4 goes in evenly to 12. 4 is the greatest common factor. That's our process. If that made your brain confused, you're going to keep working through this one. Find the GCF of 21 and 35. Make a birthday cake. And some of you already mentally have that down, which is awesome. If you don't, and even if you do, today you're still going to start out with me making a birthday cake. What number goes evenly into 21 and 35? I don't know it's 7. I'm going to choose a smaller number. What do you think, Daniel? 3. Let's go 3. So we're going to divide 21 by 3. That's 7. 3 by 35 is, wait, does it work?
No, it doesn't.
Oh, it doesn't. 3 can't go into 35. It is 7, you're right. 7 goes into 21 3 times. 7 goes into 35 5 times. This time I don't have anything that goes into 3 and 5, so I'm going to pause there. Check your voice, please. And I am just going to look at the 7. Well, there's no other number to multiply it by, so 7 is your answer. 7 goes into 21 and 35 evenly. 3 and 5 are the simplest they can be. Check out the GCF of 5 and 18. Make a birthday cake. Can anything go into 5 and 18 evenly? I'm checking 2, no. 3, no. 4, no. 5 can't divide into 18. So this is actually prime, and it's just 1. 1 is the only number that goes into 5 and 18. 5 is called a prime number, and that means it only has 1 and itself as factors. Excuse you. We're going to look at 5, a few other problems. What are some other numbers that are prime? I can't divide 5 by any number except for itself and 1. What is another one, Reason? 19 is one of them. Another one, Colton?
3.
A 3 is one. What's another one? Jackson? List them if you haven't already. Chad? 7. 5 was one we just worked with, right? Liliana? 23 is also one, yeah. Mara? Yeah. 9? 9 is 3 and 3 and 1 and 9, so we're gonna pause on that. That one's close to being prime, but it's got 3 factors. Aiden, last one.
3 billion.
No. 2 can go into 3 billion, believe it or not. But good try, Lauren. Yeah. Okay. That's as many as we need to list. You only have to have 2 or 3, that's fine. There's a lot of other numbers that you could research.
19 doesn't work.
Yeah, 1 and 19 are prime. What other number goes into 19? 2, not 3, not 4, not 5. Yeah, it is 19. Okay.
What about 2 billion and 1?
2 billion and 1, I'm not sure. I'd have to research it. 2 billion and 1 could possibly divide by an odd number. It wouldn't divide by 2 because it's odd, so 2 can't go into 1 billion and 1. Yeah, I think it's prime. I don't know though. You're going to blast off to bronze. This is independent work, so you're going to spend about 10 minutes working independently. If you are all done, I have to check your work before I can give you permission to start homework. If I check your work and I just see this as the answer, this probably isn't the answer, but let's just say it was 2, and then you say 3 here, I'm like Aiden talking to, I'm probably going to give you a blank page again and have you go back because I need to see this work. You need to show the work for today. Starting Monday, if you get anything, if you get a fraction problem Monday, and I've checked you off for not showing work for the upside down birthday cake, you may have a chance of not showing this work, but today you need to. Okay. Be really careful. 3 is looking a little fishy to me. Don't go on autopilot. Pause on 3 and look at the answer. You're on independent now, so partners are going to be halted until we get to goal.